Hi everybody, welcome to POSIX, Reading and Writing for Dummies, by Rachel Boy
and Zach Homans.
So, POSIX, turns out totally a thing.
But don't be surprised if you haven't heard about it.
POSIX stands for Portable Operating System Interface, and it's what most APIs use to interact with the operating system or operate on files.
Here's the deal. It's fairly low level, lots of other languages such as Java or C++ implement it, and chances are you won't be using it yourself. But it's still a good idea to know so you understand how exactly the computer reads and writes files.
Now, when we refer to files, we're used to using file paths. These can either be relative paths, which start in the working directory and go into subdirectories, or absolute paths, which begin with a slash and start in the root directory.
Files also have an associated file descriptor. Each process has a table containing the paths of its open files. The file descriptor is the index of a particular file's file path. Example file descriptors could be 0, 1, 2, 179, or really any whole number. File descriptors are useful because there is no unnecessary information attached to them. The process can pass around the file descriptor with ease, instead of passing around a bulky file path.
Files are assigned the smallest available file descriptor when they are opened by a process. So, for example, we could call open on corgi.jpg and have it assign the file descriptor 179, meaning it is in the 179th index of the file descriptor table. But if we decided to close corgi, the file descriptor would be freed up. Then, if we opened another file, it would assign the smallest available file descriptor, in this case 179, again.
There are three particular file descriptors in POSIX that can be considered special. First, we have 0, which is always directed to standard input. Second, we have 1, which is always directed to standard output. And finally, 2, which is directed to standard error. While we can call these file descriptors by their integer value, it is generally more appropriate to call them by their names assigned to them in the standard library, such as stdin_fileno for standard input.
Of course, these standard descriptors don't have to point to the same thing all the time. By changing the entry in the file descriptor table, we can redirect the standard input, output, and error without the process ever having to know about it. From the shell, this can be done using the greater and less than signs. Within the process, this can be done by closing the appropriate file and immediately reopening whichever one you want in its place. So, how do we actually open a file? Well, we do that by calling the command open, which places the file path in the file descriptor table and returns the appropriate file descriptor. Open takes a variable number of arguments, but its first argument is always the file path. This can either be the relative file path from the current working directory, or the absolute file path.
The second argument is always the options. Basic options include write-only, read-only, and read-write. But there are also other potential options one can use. oCreate opens a file, but if that file doesn't exist, it creates it. oTrunc opens the file, but then immediately truncates it, removing all current information within it before the open function returns. Multiple options can be used at once using a pipe to separate them. A third option for open is sometimes used for extra options, including specifying permissions when creating a file.
It's worth noting that you, the programmer, probably won't use open much. Open is the function that your library will use when you call something like fopen.
POSIX can be used to gather metadata from a file as well. Metadata is the information about a file that's not actually part of the file. For example, information like permissions, last access time, and ownership are all pieces of data that are stored with the files, but not in the files. To write metadata, you can use functions such as chmod to change permissions, utime to change last access time, and chown to change the ownerships. If you wish to read metadata from a file, simply use the function fstat.
Now that you have a file open, you might want to read or write its contents. There are three common methods for the operating system to do this that we'll give a brief overview of. The first and simplest procedure is mmap, which is short for memory mapping. ImMap puts the file in the process's address space and allows straightforward loads and stores to handle reading and writing.
The other two methods are very similar in that they both access the file externally, meaning that they only move copies around instead of actually moving the file to the process's address space. pread and pewrite read and write at a specific position in the file, while read and write operate sequentially, with each portion of the file being either read or written one at a time. Each of these has a different potential use.
So that's the basics of reading and writing files with POSIX. To summarize, here are the key points. Files are represented with file names and integer file descriptors. The standard descriptors 0, 1, and 2 are special. Open assigns file descriptors to files, and close removes that association. POSIX also has standards for reading and writing metadata, and it has several options for how to read and write content to and from a file.
And with that, it looks like the cat's out of the bag.